Now let's talk a little bit about the concept of function. Now we continue with lesson 3.1. In mathematics, in algebra, this is the context we are going to be using to define the term function. Function then is a relation. I think it's going to be important for us to take notes. Is a relation where each input, all right, remember the input and output from our previous video, where each input has only one output. And this is the essential definition of a function in terms of mathematics. Each input has one and only one output. That relation is now going to be called function. If there is a relation where even just one input has more than one output, then that relation cannot be called a function. So let's take a look at some examples to understand what it means. As you can see, you have some coordinate pairs in this list. So remember that the way that we write coordinate pairs are by writing the x value first and then its corresponding y value later on. So in this case, I see that if you entered this number -2 in the function machine, then you would get 2 as the output and so on. So you could actually convert this into a table like this, where the x inputs are going to be located in the top row. So you see -2, the output is 2. For -1, the output is 2. For 0, output 2. For 1, the output is 0. And for 2, the output is 0. So as you can see from this example, each input, for example, -2, has only one output. And you do not see -2 elsewhere on the top row. -1, 0, 1, and 2 have each of them just one output. So in this case, I could say that this first list of numbers tell me that this is a function. Now, let's analyze the second example and see what happens. And I have to remember the definition of function. It's a relation where each input has only one output. If I want to convert this into a table to make things better to see it, I have 4 with the output 0, and 8, and the output is 7, and so on. If I complete this, now I want you to notice something. Hope that you can see it already. As you can see, number 4 input, number 4 input. So 4 has 2 different outputs. They are 0 and 3. So in this case, 4 has 2 different outputs. Based on our definition, this is not possible for it to be called a function. So this is not a function. All right? If you look at at C, we can analyze the same thing. And we have the list of inputs. And here, 0 has 2 different outputs. So I can conclude that this is not a function. Let's take a look at another way of representing functions. There is a list of input here. Let's take a look at example D, of course, and the list of outputs. Well, -1, how many outputs do you see for -1? Just one. Okay. Number 3, how many outputs? It just has one output. Number 11, it just has one output. Even though they share the same output, you still see that we are satisfying the definition of function, that each of the input has just one output. So it means that D can be said it's a function. Okay? Hope it is understood. If not, remember you can always talk to me and clarify if necessary.